And today I'm going to talk about CPU organizations, one of the important topic in computer organization and architecture. So, dear students, there are three types of CPU organizations, which are accumulator based, GPR based, and stack based. So, depending on the uses, number of registers, and as per the need, different organizations are possible. Before starting the discussion, let me tell you that in the earlier 1950s, after the Second World War, the Department of Defense at USA, they asked their scientists and mathematicians to develop the computing devices and optimize the resources. In this process, different mathematicians and scientists developed the different organization schemes, and initially, when there were 4-bit and 8-bit registers, then accumulator-based organization came into picture. So as the name suggests, accumulator means collection of the content. So initially there was very less number of registers, very less computing needs were there, and so the resources were required very less. And the most of the operations were being done with the help of accumulator as an intermediate operation and the storage device. After that, when the need increased, the general purpose register organization came into picture, and a lot of registers as an intermediate were being used as a temporary storage. And then when the need was increasing very fast in the exponentiation speed, then the stack-based organization came into picture. So in general purpose registers, we know that the registers are being used to store the data in intermediate storage as a temporary storage, and the results are stored during the program execution. It can be accessed with the help of accumulator or data register or index register or temporary registers. Special purpose registers are those which are used for specific purposes, and these registers are for processor internal processing. So like program counter, which is used to store the address of the next instruction, memory address register, which is used to store the memory address, memory data register, which is used to store the content, and instruction register for storing the instruction, and flag register for storing the different Boolean operations like carry, like status, like 0, and sign bit of the output. As an important point, we can say that these are used to help in the basic operations of addition, shifting, and complement, etc. So there are arithmetic operations like subtraction, multiplication, and division, which are performed with the help of basic operations of addition, shifting, and complement. So dear students, we are discussing here about the different classification of registers, which are accumulator, MAR, MDR, and different general purpose registers like R0, R1, R2, and different Rn up to the temporary storage number of registers are there. I talked already about the program counter and the instruction register and the index register. Stack pointers are also used to point the top of the stack. When the stack is being pushed, then the stack pointer is incremented by 1, and when it is being popped, it is decremented by 1. Segment pointers in a machine with segmented addressing. This segment register holds the address of the base of the segment. Control and status registers are used to control unit to control the operations of the processor. PSW, program status word, it is a group of bits to contain the status information. A status can be a sign bit or a 0 flag or a equality, or to check the overflow, or to check whether it is an interrupt or not, enable or disable, flag, and supervisor flags. So while discussing the different processor organizations, we can say that the processor organizations are of three types mainly: accumulator-based organization, general-purpose register-based organization, and the stack organization. So if we see here, there are different types of address instructions. 0 address instruction, 1 address instruction, 2 address instruction, and 3 address instruction. So these numberings are basically given as per the number of the operands after the operator or the instruction code. So like this, here we can see here that this is a push operation and one operand is there, so it is a one address instruction. This is the add operation and there is no operand is given, so it is a 0 address instruction. So when we will use push A, then the A is pushed in the stack, and then when we write push B, then B is pushed, and when we use add operation, then B is popped, A is popped, and both are added, A plus B, and again pushed into the stack. So in this kind, whenever we do push C, then C is pushed, and when we push D, D is pushed. And when we use D add, then D and C are popped, and C plus D is pushed into the stack. Similarly, we can talk about the multiplication. It is 0 address instruction. In one address instruction, as I already told, that the accumulator is being used by default in implied mode, like load A. So the accumulator, its meaning is that the memory content at the address location A is shifted in the accumulator. In add B, the accumulator is in by default, so accumulator content and the content at the address location B are added and again shifted to A accumulator. Store T, it means the accumulator content is stored at the T location in the memory. Load C, similarly as load A, the content at the address location C is used in the accumulator. So in one address instruction, we can say that the accumulator is being used as by default and the operands are being applied with the help of accumulator and different operations are being done. So here we talk about the two address instruction like move R1A. So we can say that the content at the address location A is being shifted towards R1. Add R1B, so R1 and content of B address location is being added and shifted towards R1. And similarly, we can interpret about these instructions. So I'm sure that you are clear about the two address instruction where two operands are being used. In three address instruction, there are three operands in instruction with the operator R1AB. So content of A at location A and content at the location B are added and they are shifted towards R1. Add R2CD means the content at location C and content at location D are being added and they are shifted towards R2. So here we can see that there are three operands and so it is a three address instruction. So my dear students, we can see here that the general purpose registers are using the temporary registers for their operation and they are in number more than the accumulator. So advantage of general purpose register is that they are more efficient as CPU increases as they are large in number and they use less memory space and so instructions can be written in a compact manner. Disadvantage is that care should be taken to avoid unnecessary uses of the registers. Since large registers are being used, so extra cost is required. So general purpose register organization is costly. So general purpose register organization, CPU is using less registers, but this is costly. Now, if we compare it with the stack-based organization, so it is using the stack as intermediate data structure, and it is using LIFO, last in first out structure. The main two operations are push and pop. We have already discussed the advantage is that it is efficient, execution of instruction is faster, and length of the instruction is shorter as they do not have address field. But the disadvantage is that it is always lengthy in the program size. So if we want to make a compact program, we have to prefer the general purpose register organization instead of a stack-based organization. So here we have an example that we can see here, we can solve a numerical. Like with the help of RPN notation, reverse Polish notation, we can say applying the BODMAS rule, and it is in infix 3 into 4 plus 5 into 6. So whenever it will be written in the postfix notation, it can be written as 3, 4 into multiply, then 5, 6 multiply, and then the plus operator. One by one, it will be pushed into 3 is pushed and 4 is pushed, and whenever operator comes, then both the operands are popped and they are being applied and again pushed to the stack. Similarly, 5 and 6 are different operands, so these are pushed into the stack, and then whenever we get a star operator, then 5 and 6 are popped and multiplied there, and the 30 is pushed into the stack. Again, we get the plus operator, so 30 and 12 are popped, and the 42 sum is pushed into the stack again. So this will be a reverse policy notation where we use the difference 0 address and 1 address instruction to execute it, and we can apply it to the stack. So here, my dear students, we can see that the different general purpose and stack-based organizations are good, but comparatively, we can see that the accumulator is very lengthy and costly, and general purpose register organization is better than the other two accumulator-based and stack-based organization. So thank you for listening.